All right, so today we move on to lesson 3.7, which is evaluate determinants. So pause the video, take a look at the problem of the day, answer the question. So in 3.7, we call it evaluate determinants. So a determinant, let's talk about that first, is a real number that is associated with each square n by n matrix, denoted by either DETA or the absolute value A is determinant A. How you evaluate a determinant here is you take the diagonal, so you do AD minus CB. And it says the determinant of a 2 by 2 matrix is the difference of the products of the elements on the diagonals. All right, so let's use that to do an example. Let's write an equal sign. Now, I like to normally draw through them like you see it here. So we do AD, so I always go down first. So you see I cut through my down diagonal from left to right. So we get what? 5 times 1. And put a minus, then I do the up diagonal. 3 times 4. I'm going to switch to typing here. So what I get is I get 5 minus 12, which equals negative 7. So my determinant A is negative 7. So it's a single number. We take the matrix and we turn it into a number. Okay. Now, the determinant of a 3 by 3 matrix, it's a little more complicated. You want to write this in your notes. Repeat the first 2 columns to the right of the determinant. So you have a 3 by 3. You see this column, we rewrite it. And now you're doing the diagonals again, but you'll see I go down first. So I do A, E, I, B, F, G, C, D, H. So we have 3 diagonals going down, and then 3 diagonals going up, minus all of the up diagonals. So let's take a look at an example doing this. So first thing, oh, and actually, I'm sorry about that. So step 2 said subtract the sum of the red products and the sum of the blue products. Here's the red, here's the blue. So example 2, evaluate the determinant of the matrix. We first have to start by rewriting my first 2 columns. So I get 2, 4, 3, negative 1, 1, negative 4. Space them nice here. So I rewrite the first 2 columns here. Now, I'm going to put, actually probably going to type these as I go. I'm going to go back and forth. Okay. So I'm going to subtract, I'm going to put a parenthesis here. Now the first diagonal, I'll do one at a time. We multiply 2 times 1 times 2, and actually draw the line through them. So 2 times 1 is 2, times 2 is 4. So are we okay with me just writing what they multiply to? It's 4. Actually, I gotta move this a little bit. All right. Then I do my next down diagonal, negative 1 times 0 times 3. Negative 1 times 0 is 0. 0 times 3 is 0. Put plus 0. Then I do negative 3 times 4 is negative 12. Negative 12 times negative 4 is positive 48. That's my first set of diagonals. They're all in a parenthesis. Are we okay so far? Now we're going to go minus all of my up diagonals. So let's use a different color. They used red in this, so I'll do that red as well. So 3 times 1 times negative 3. 3 times 1 is 3, times negative 3 is negative 9. All right. Negative 4 times 0 times 2. Negative 4 times 0 is 0. 0 times 2 is 0. And then 2 times 4 times negative 1. 2 times 4 is 8. 8 times negative 1 is negative 8. And that is how I do my determinant. Now from here we simplify the parentheses. 48 plus 4 plus 0 is 52. Minus negative 9 plus 0 minus 8 is negative 17. negative 52 plus 17, which is 69. So my determinant, my 3 by 3, is 69. All right, so for the next part, area of a triangle. Here's a practical application of using a 3 by 3 determinant. You can use a determinant to find the area of a triangle whose vertices are points in a coordinate plane. So area of a triangle. The area of a triangle with vertices x1, y1, x2, y2, and x3, y3 is given by this. Put your ordered pairs going the 1s, 2s, and 3s. Put 1s all in the column, the plus minus 1/2. Where the symbol plus minus indicates that the appropriate sign should be chosen to yield a positive. So we want the answer to be a positive in the end, positive value. What do you know about a triangle? Don't you know area is 1/2 base times length? So that's sort of where we get the 1/2. Triangle is usually half of a rectangle. All right. So example 3, off the coast of California lies a triangular region of the Pacific Ocean where huge populations of sea lions live. The triangle is formed by imaginary lines connecting Bodega Bay, the Farallon Islands, and Ano Nueva Island as shown. Use a determinant to estimate the area of the region. All right. So I have all my ordered pairs. Now I'm just going to start to type them in here. So I'll do Bodega Bay first. So in your box, you have -1, 41. If you notice, I always put a 1 there in the end. Then let's do the Farallon Islands. No, excuse me. Let's do Ano Nuevo Island next. So we have what? 38, -43. And add that 1. Make sure I have enough space between these here. All right. Then my last ordered pair is 0. And add a 1. So I'm making a matrix based off of my points. And I also have a plus minus 1/2 in front. So we're going to do the determinant again. If you remember, we're going to copy all of these here. So, and then we'll deal with the 1/2 at the end. So repeat the first two. I have -1, 41, 38, -43, and 0, 0. So I'm repeating the first two columns, and we're going to do the determinant again. So we're going to multiply out. We get -1 times 43 times 1. So I'll write the 1/2. So when we multiply out, we get 43 plus the next one, 41 times 1 times 0, which is 0. All right. And I'll show you that. It's the 0. Then we get 1 times 38 times 0, which lo and behold is 0 again. We're going to minus the other diagonal going up. So 0 times -43 times 1 is 0. Then we get plus 0 again, plus 1558. We'll put two sets of parentheses here. So we're going to evaluate that first. And here's my other diagonals. So when we simplify with the 1/2, we get 43 in the first one minus 1515 with the 1/2. And then when we simplify that, plus minus, we get 1/2 times -1515, which will just equal, area will equal 757.5 miles squared. That's my answer. Now it's a plus minus. You see it's a negative, so we want the negative version of it times the negative to get us this answer. So here's a practical application of using the determinant, a 3 by 3 determinant. All right, so now we take a look at something called Cramer's rule for this lesson. Do you know how in the BM chapter 3, this is a long time ago, you solved systems of equations? Do you remember the terms graphing, substitution, elimination? Well, we use those three methods to solve a linear system, such as this: ax plus by equals c, cx plus dy equals f. Well, you can actually use matrices, as you can see here, to solve them. And where it also comes into play, you'll see we'll do a 3 by 3. What if we have x, y, and z we're looking for? So the more knowns you have, the harder it is to do it algebraically. We end up using matrices for it. The coefficient matrix is A, B, C, D. Where does that come from? All the coefficients in front of x and y. So let's take a look at what Cramer's rule is. Cramer's rule for a 2 by 2 system. Let A be the coefficient matrix of this linear system. Determinant A does not equal 0. Then the system has exactly one solution. And here's the solution. To find x, you do EF over BD. And if you notice here, EF, BD, they're the coefficients and other numbers that are not x. So I remember when I do x, I don't actually use A and C. Over your determinant A. Determinant A comes from here, coefficient matrix. Y is AC, EF. So AC, EF. I'm looking for y, but I don't actually use y's coefficients, which is B and D, over determinant A. So let's see how we actually solve an ordered pair for that. All right. Before we start to, I'm going to type them here. So the 9 is your A, just so you have a quick reference. Your B, so I could do it here. So A is the 9. Let's just do this here. My typing is giving me a little trouble here. So this is A. I think I could fit that there. This is B, is the 4. C is 3. D is -5. Then E and F are the numbers here. E is -6. F is -21. Now if you see, we start off by determinant A. Determinant A is the matrix, or the coefficient matrix. So that's what? 9, 4, 3, -5. So 9, 4, 3, -5. So we start with this. And how we do it, if you remember before, is we do the diagonals. Here we start off this diagonal, 9 times -5. 9 times -5 is -45 minus the other diagonal, 3 times 4 is 12. And you get -57. All right, so that's my determinant. My determinant A is what I'm actually going to use if we go back for a second. You look in your notes. I'm going to use it for the denominator here. All right, now for x, I need EF over BD. So now we got to set up x. We do x and y. So BF, EF I should say, is -6, -21. And then I do BD as well. 4, 5. And that's all going to be over determinant A. So put my lines here. Over determinant A. So what does that mean for us? All right. So top, I do the same thing again. Negative 6 times negative 5 is 30, right? Minus the other diagonal, which is negative 84, right? Because I have negative 21 times 4. Over determinant A. Determinant A is this number here. It's negative 57. So if I find determinant A, I use it for both of them. And then up top, 30 minus negative 84 is 114. Over negative 57. And when I divide them out, I simply get negative 2. So x in my ordered pair is negative 2. All right. Now we gotta do the same thing again, but for y. I already did determinant, so we're gonna look right at the y part. I'm gonna do it up. Oh, I have room down here. Okay. So y equals. If I look at my y, and you have to go back to your notes here, we do AC, A over C, E over F. So AC is this column. So 9, 3. And then we need EF. Negative 6, negative 21. All over determinant A. Again, they're both over determinant A. All right. So let's do the same thing again. I go the down diagonal first. 9 times negative 21 is negative 189. Minus the up diagonal is negative 18. Right? I'll show you that. 3 times negative 6 over determinant A. Oh, which actually is just negative 57. I'll just type it already. Then we simplify. I get negative 171 over negative 57, which equals 3. So my answer, I'm going to write as an ordered pair here. You get negative 2, comma 3 as my answer. So there's how we use determinants and matrices to solve an ordered pair. Now you could do substitution elimination or graphing. You're going to get the same answers. All right, but algebraically, but here's the way to do it with a matrix. All right. So we're doing Cramer's rule again. We have a 2 by 2. We're going to look at what a 3 by 3 means. Because we did determinants for 3 by 3 as well, right? So let A be the coefficient matrix of linear systems shown below. AX plus BY plus CZ. When we have a third variable, we have 3 equations. So read through that. Coefficient matrix is the 3 by 3. So then we have to solve for x, y, and z using each of these matrices. If determinant A does not equal 0, then the system has exactly one solution. How I remember it, and I could actually explain this pretty good here. All right, with x, I don't use the x coefficients. So where the x coefficients are, you put JKL, put what it's equal to. Why we don't use the y, it's in the middle here, JKL. We use the other two. And then JKL here, and place the z. And actually, I probably should have said that to give you a little bit of a better explanation. So yeah, where x is, so here's the y, BD, right? Where x's should have been, we use EF because we don't want to use x. And then here we use x when we don't want to use x, or when we don't want to use y because we're solving that, we plug in the e's and f's. So that's actually how I remember without all these crazy letters. All right. Here's a common real life example with 3 by 3. And like I said, you're just going to have to look at your notes to do this. Atomic weights of 3 compounds are shown. Use a linear system and Cramer's rule to find the atomic weights of carbon, hydrogen, and oxygen. So I'm giving you a chemistry problem. All right, well, we're going to start off by writing the equations because I don't give you that. Look at glucose. You have what? 6 carbons. I'm going to write 6C plus 12H plus 6 O's for oxygen equals 180. So this is how we actually write our equations here. Let's do carbon dioxide. So 1C, there's no hydrogen, so I'm going to move over here, plus 2 oxygens equals 44. And we're going to do the same thing here. We have carbon, so we're going to do 2 hydrogen plus 2 oxygen equals 34. And if you want to, maybe we should go back. What do we have? We have 0 hydrogens. This might not be bad to actually add 0 to them. And this is what? 0 carbons. So now we have all our numbers here. We start by doing determinant A. I'll do that up here actually. Determinant A is going to be all 3 of these coefficients. So 6, 12, and 6. Where am I getting that? 6, 12, 6. Next row, 1, 0, 2. Last one, 0, 2, 2. Now, if you remember with our matrix, I'll always have to redo the first 2 columns. So I have another 6 and a 12. I have another 1 and a 0. Another 0, I have another 2. All right, so let me show you where my determinant ends. Remember how I said I repeat these 2 rows. So you're going to find the determinant here. I'm going to pause and solve it, and I want you to check your work. We do each of the 3 down diagonals and then the 3 up diagonals. All right, so just like before, with determinants, we do our 3 down diagonals, which is here, minus the 3 up. And when we simplify, I get negative 36. Now I'm going to set up the x, y, and z here, and I'll talk about them next. I want you to try to set them up yourself first. Okay, now I want you to please pause the video and copy this down. I did not do the work for the determinant, like you know how the determinant, I did the determinant with all 3 parts. When I do that, I get negative 432. When I do that here, I get negative 36. When I do that here, I get negative 576. So please make sure you rewrite the 2 columns, do all the down diagonals minus all the up diagonals, just like determinant A. So what we get in the end is we get that carbon is 12 for the atomic weight, hydrogen is 1, and oxygen is 16. So here's a practical example of how we could use matrices and determinants to solve something using Cramer's rule. All right, that's it for today. Problem of the day is your homework, and then complete these 4 problems, 1, 10, 16, and 19 from assignment